This is the second part of the CHUMP 4-bit computer project, the program memory. This is the part of CHUMP that holds the lines of code to be interpreted and executed by other parts. It takes input from the program counter to keep track of the line currently being executed, and outputs the corresponding 8-bit operation, consisting of the opcode in the high nibble and the constant in the low nibble, a structure which I explained in my last video. So how do I program the EEPROM? For this, I have a separate board that has a slot for an EEPROM IC wired up to an Arduino. The EEPROM I'm using here is an AT28C16 EEPROM, which has 11 address pins to select between its 2048 addresses, 8 I/O pins to program or read from, and 3 control pins that control the mode of the chip. To write to the chip, output enable is set high, and chip enable is set low, which are both active low pins. Then the address is selected by manipulating the address pins, and the data is outputted on the I/O pins before write enable is quickly pulsed low to write to the EEPROM. That's also an active low pin. Since the control EEPROM, which interprets the code, has not been added yet, and because having a way to verify this is working is helpful, a dual 7-segment display is used to display the operations in hex. Since one hex digit can represent 4 binary bits, the opcode can be displayed on the first digit while the constant is displayed on the second. For example, a read 12 operation would appear as 8C. However, this requires some method of converting the binary numbers into bytes, which represent which segments should be turned on or not on the displays. For this, 2 more EEPROMs are used, containing lookup tables in addresses 0 to 15. One is used for each digit so that multiplexing is not necessary. Finally, I've cleaned up my board, compacting my clock into the bottom left corner and simplifying the logic circuit to just 4 NAND gates, as well as labeling the ICs to make everything more readable and clean moving on.